Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. My name is Kurnia Ramadan Tito Aza. I'm from Informatic Engineering NPM 2332183. This I want explain you about computer organization and architecture. 1. Introduction to computer system. Computers are tools of humans with a working system that receive input in the form of data, process the input, and produce output in the form of information. Computers divided into four parts. Input. Input have keyboard, mouse, scanner, and others. Output have monitors or other graphic displays, printers, speakers, and others. Processing data is the function where the computer actually does its job, namely manipulating and controlling data from the entire system. Manipulating here is from raw data to a more informative form or information, and less storage, hard drive or external storage device. 2. Compilation system. Have programming language. A programming language is a language that is meant for humans to communicate with computers. The unstructured human mind must be structured so that it can communicate with computers. Computers require certainty and correct logic to be able to carry out certain instructions. For this reason, a good and correct algorithm needed. 3. Machine language. Machine language is a language that contains machine codes that can only be interpreted directly by computer machine. Machine language is often also called native code. It really depends on the particular machine. This language is the lowest level language and is in the form of binary code 0 and 1. A collection of introduction in machine language can from microcode or a kind of procedure in machine language. Assembly language or mnemonic code. It is a symbolic form of machine language considered to be the first programming language in the form of strings, and it's easier for humans to understand. Its machine language code has its own symbols in assembly language. 5. High-level language. This language is closer to human language. This language also provided many facilities to make programming easier. For example, variables, data types, contains, control structure, loops, function, procedure, and so on. 6. Hardware organization. Computer hardware is all the physical computer and is distinguished by the data that is in it or that operator in it, such as motherboard, power supply, processor, RAM or random access memory, hard disk, CD drive, CMOS battery, VGA card, sound card, etc. Next, bus system type. The customer is very important. The customer will be followed by the customer, but now we live. We need some tricks, but now it's clear. Let it be said that the layer must be in. To decorate in the sky. Tanpa diet before errors, bird parta X, alleviate. Bus system type divided to 1. Dedicated bus. A dedicated bus is a bus that specially transmits certain data only. This bus has 8 pins of high speed, but it also has the disadvantage of requiring a lot of channels. 2. Multiplexed bus. A multiplexed bus is a bus that transmits data through the different information, be it data, address, and control signal in a multiplex manner. Performance issues. Instruction execution rate. A processor is driven by a clock with constant frequency f or equivalency, a constant cycle time where t 1 for f define the instruction code. LC for a program as the number of machine instruction executed for data program until it runs to completion or for some definite time interval. Not that this is number of instruction execution, not the number of instruction in the object code the program. The processor time. The time to processor depends on the memory cycle time, which may be greater than the processor cycle time. The Y performance factors in the preceding equation LC, P, M, K, T are influenced by 4 system attributes. 1. The design of instruction set, or known as instruction set architecture. 2. Compiler technology. How effective the compiler is in producing an efficient machine language program from high-level language program. 3. Processor implementation. 4. Cache and memory hierarchy. Computer components. Contemporary computer designs are based on concepts developed by John von Neumann at the Institute for Advanced Studies, Princeton, referred to as von Neumann architecture, and is based on 3 concepts. First, data and instruction are stored in a single read-write memory. Second, the contents of this memory are addressable by location without regard to the type of data contained there. Third, execution occurs in a sequential fashion unless explicitly modified from one instruction to the next. Hardwired program. The result of the process of connecting the various components in desired configuration. Page cycle. Page cycle divided into 5 parts. 1. At the beginning of each instruction cycle, the processor pages an instruction from memory. 2. The program counter or PC holds the address of the instruction to be paged the next. The processor increments the PC after each instruction page so that it will page the next instruction in sequence. The fetch instruction is loaded into the instruction register or ER. The processor interprets the instruction and performs the required action. Selanjutnya, have interrupt cycle divided for 8. 8 the interaction cycle. Next, processor checks for interrupt indicated by an interrupt signal. If no interaction, page the next interaction. If interrupt pending, suspend execution of the current program. Save context, set PC to start address of interrupt handler routine, process interrupt, restore context, and continue the interrupt program. A top-level view of the computer function and interconnection. Data bus. Data lines that provide a path for moving data among system modules may consist of 32, 64, 128 or more spirit lines. The number of lines is referred to as the width of the data bus. The number of lines determines how many bits can be transferred at the time. The width of the data bus is a key factor in determining overall system performance. Address bus use the designate the source or destination of the data on the data bus. If the process wishes to read a word of data from memory, it puts the address of the desired word on the address line. Also used to address I or U ports. The headers or the bits are used to select particular module on the bus, and the lower order bits select a memory location or I or O port within the module. Control bus used to control the access and the use of the data and address lines. Because the data and address lines are shared by all components, there must be means of controlling their use. Control signals transmit both command and timing information among system modules. Timing signals indicate the validity of data and address information. Command signal specify operation to be performed. Next, the memory hierarchy, locality, and performance. Memory. Memory is the part of the computer where program and data are stored. The term store or storage refers to memory, although the word storage is often used to refer to diskette storage, a place for information read and writing. Various types, technologies, organization perform and priced. Memory parameters. There are four important parameters are considered in choosing a memory. 1. Capacity. Memory can be viewed as a storage unit containing one number of location each of which is storage with number of bits. Speed. The memory speed is measured in terms of two parameters, a trace time or TA and cycle time or TC. Latency. The access time for the first access is in a series of access. Bandwidth. The data transferred by the memory is expressed at the number of bytes per second. Bit and byte. Bit base unit of memory. Binary digit consists of the number 0 and 1. Byte. 1 byte sama dengan 8 bit. 1 kilobyte sama dengan 1024 bit. Characteristic of memory systems. Location refers to whether a memory is internal or external to the computer. Internal memory is often equated with main memory. Processor requires its own local memory in the form of registers. Cache is another form of internal memory. External memory consists of peripheral storage devices that are accessible to the processor via I or O controllers. Capacity memory is typically expressed in terms of bytes. Internal memory, RAM or random access memory. Random access devices allow store directly accessible data in random order. RAM technology is divided into two technologies: dynamic RAM or DRAM, static RAM or SRAM, synchronous DRAM or CDRAM. Access is synchronized with an external clock. Address is present to RAM. RAM finds data CPU waits in conventional DRAM. Since CDRAM moves data in times with the system clock. The CPU knows when data will be ready. CPU does not have to wait, it can do something else. Burst mode allows CDRAM RM to set up stream of data and fire it out in block. DDR CDRAM sends data twice per clock cycle or leading and trailing edge. Cache DRAM. Mitsubishi integrates small CRAM cache 16 KB onto generic DRAM chip. Use as true cache 64-bit lines effective for ordinary random access. Mitsubishi integrates small CRAM cache 16 KB on the generic DRAM chip. Used as true cache edge refers the bitmap screen. CDRAM can pretest data from DRAM into CRAM buffer subsequent access solely to CRAM. Thank you. That's all about my presentation. If I have kesalahan, mohon maaf. Wassalamualaikum warahmatullahi wabarakatuh.